right, so now we're going to get into the next part of our exponent unit, which is dividing exponents. So our EQ is how do I divide exponents? By the end of this, I hope you can make sure that you got that. Print out the notes from the classroom, and it'll go right along this, okay? So the first thing we're going to do, is we're just going to write these out. So this is 3 to the 5th, so this would be 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3, okay, because it's 3 cubed. So 3 divided by 3, that's 1, so that goes away. 3 divided by 3 is 1, 3 divided by 3 is 1, so what we're left with is 3 squared, okay? So bottom one, we've got 3 times 3 times 3, 3 cubed, over 3 times 3 times 3 times 3 times 3. Okay, so that would be gone, gone, gone. So it'd be equal to 1 over 3 squared. Okay, so this right here, 1 over 3 squared, we'll get back to that. But you see that this goes to the property. We've got m, a to the power of m, divided by a to the power of n. So they have the same base, but you're dividing by different powers. Well, you're just subtracting. Okay. Remember, so 3 minus 5 would be -2, right? So that's why we get 1 over 3 to the positive negative, or to the positive 2, because whenever you have a negative exponent, you just put it over the top. 1 over whatever that number is. Okay. So we'll get there. So when you divide terms with like bases, so right here we've got like bases of 3, and we divide terms, you subtract the exponents. So whenever you divide, you're going to make sure to subtract those exponents. The like bases don't get divided. So right here we didn't, change the base to 1, 3 divided by 3. No, we're just keeping the base. Always subtract top minus bottom powers. So top minus bottom. So 5 minus 3 is 2. 3 minus 5 is -2, and that's why we put it 1 over 3 to the positive 2. Okay, so we're going to go over a bunch of these. Here we go. So right here we've got 2 to the 8th minus 2 squared, which would be 2 to the 8 minus 2, which is equal to 2 to the 6th. Right there. Okay. Right here we've got x to the 7 minus 3, which is equal to x to the power of 4. Okay, right here we've got y to the 3 minus 5, okay, which equals y to the -2. Okay, so that'd be equal to 1 over y squared. Whenever you have a negative exponent, okay, you're going to put it on the bottom of a fraction, 1 over y squared. Now, if you have, we'll get to this, but if you have multiple bases, and some of them have positive exponents, some of them have negative, the negative goes on the bottom and the positive exponents stay on the top. Okay, right here we've got x to the 5 minus 2, so that would be x to the 5 minus 2, and y to the 7 minus 4. Okay, so that's x to the 3, y to the 3. Right there. Okay, we got 5 minus 2 is 3, 7 minus 4 is 3. Okay, and you only do it to the like bases. All right, right here we've got a. All right, so we have a 6 minus 5, a to the 6 minus 5, and b to the 2 minus 7. I'm going to get a negative. So it's going to be a to the 1, and then b to the -5. So a to the 1 is just 1, a, right? Anything to the, like 2 to the power of 1 is just 2. All right, so then we're going to put this on the bottom, so it'd be, we'll just do the last one, be a over b to the 5th. And the reason is when you have a negative exponent, you're going to go ahead and put that on the bottom. Okay, over here we've got a lot of stuff going on, so we'll just go underneath. We got x to the 8 minus 3, x to the 8 minus 3, y to the 3 minus 9, and then z to the 5 minus 1. Okay, so then we'll do that math. We've got x to the 5th, y to the -6th, z to the 4. Now, you've got positive exponent, negative exponent, positive exponent. So all the positives stay on the top and with their bases, and then that negative exponent's going to go on the bottom. So it will be x to the 5, z to the 4 over y to the positive 6. Just like that. All right, so moving on, we've got when you have coefficients. So the coefficient is the number in front of the variable. Okay, you got your variable, so those might be your like bases. Like right here we have a and a, those are your like bases. The coefficients, okay, what do we do when we have those coefficients? Well, when you have coefficients in front of your variables, okay, divide those just the way you do in a normal fraction, okay? So we'll be reducing fractions and all that. So right here, we're just gonna do that math, okay? We can reduce this to 1/3, right? Okay, so right here, we have 12 times 7, it's 84 over 42, which would just be 2 over 1, okay? Or just 2, in this case, just do 2, okay? Right here we have 2 times 9, which equals 18. 6 times 4 is 24. Okay, so in that case, you've got 3/4. 6. 6 times 3 is 18. 6 times 4 is 24. So 4 squared, 16 times 12. It's 192. Okay, and then we have 24 times 8, right? 2 to the power of 3. 2 times 2 is 4, times 2 is 8, which equals 192, which should just be 1. We got k to the 5 over k to the 5, which is k to the 5 minus 5, okay, which equals k to the 1, or 0, which just equals 1. Anything to the power of 0 equals 1, okay? Anything to the power of 1 is itself, but 5 minus 5 is 0, so that equals 1. All right, so let's do this one. So here we go. We've got m to the 3 minus 4. Go to this side. Then we've got n to the 5 minus 5. And then p to the 7, because there's no p on the bottom. Okay? So that would just mean, that would just be m to the negative 1, n to the 0, p to the 7th. So this is going to go on the bottom just as a positive 1. This is going to be 1. This will just be p7. So our final would be p7 over m. I mean, it is m to the 1, but you don't need to put that. Just m. So p to the 7 over m. Okay? All right, now we're going to get a little bit, so we've got the coefficients here we've got to deal with. So you go back over here, you kind of see how you deal with those. We're just going to reduce that fraction to 1 over 2. That'd be 1 a to the 5 over 2, which would equal a to the 3 over 2. We've got negative 6 over 12, so that'd be a negative 1/2. Okay, and then we've got x to the 7 minus 5, and then y to the 2 minus 6. So that equals negative 1, x to the 2, y to the negative 4 over 2. Well, that y to the negative 4 has to go to the bottom, so it's actually going to equal negative 1 x squared over 2 y to the positive 4. Just like the exponent is negative. If the coefficient, which is 1, is negative, you just leave that. All right, now we're going to do multiplication and division. Last practice here. Let's put it together, okay? So first thing, let's do top and bottom. Bottom doesn't have to do anything. So we can literally go 4x to the 6th top. 8 times 2 is 16. X, 3 times 5, well, you just add them. So that's to the 8th. Okay, 16 divided by 4 is 4. X 8 minus 6, that'd be 4x squared. Multiply 8 times 2. 16 divided by 4 is 4. X times x, so 3 plus 5 is 8. 8 divided by 6 is 8 minus 6. So we get that squared. Okay, let's go to the next one. 2 times 5 is 10. A to the 7, so that'd be a 7 plus 2 is 9. Okay, so we get this a7, a squared. 7 plus 2 is 9. So 3 times 5, that's 15, a to the 11. Okay, so this is going to be 2/3. So 2/3 a 9 minus 11. So that's going to be 2a 9 minus 11 is -2/3. So that a is going to go to the bottom of this fraction and get a positive, 2/3a squared. Okay, so the a just goes to the bottom. A 3 times 6 is a to the 18, b to the 12 over a b. Okay, so this is 1, right? So it's going to be a to the 18 minus 1, which is a to the 17, b to the 12 minus 3 to the 9. Done. Okay? So a to the 17, b to the 9. All right. Now here, a little bit more. You got 3 to the power of 3, which is 27. Okay, x to the 3, that'd be x to the 9. All right, now we've got 6 squared, which is 36. And then we got x to the 2 times 2, which is x to the 4. All right, so 27 over 36. Well, the number you see is 9. 27 divided by 9 is 3. 36 divided by 9 is 4. And then x, so 9 minus 4 is 5, so 3x to the 5 over 4. Boom, done. All right. Now, if that was a negative exponent on the x, you'd put it on the bottom. Okay, so you kind of treat the coefficients here, and you treat the variables over here with their exponents. Have a great day. Stay classy.